Time to learn the final of our derivative rules. This is called the chain rule, and the chain rule is when you have composite functions. Our original functions that we've been dealing with, we can just use the regular power rule or trig function rule. Even if you wanted to a quotient rule type deal, maybe I had another one here that was like, I don't know, x plus 2 over x minus 7. Well, something with the quotient rule would be maybe it's the same thing, but maybe that whole then entire thing was, say, raised to the fourth power or something like that. All these essentially have a function inside another function. An outer function, in this case the square root, the inner function, the x squared plus 1. In this one, the outer function would be the trig function, the inside would be like this 6x. Those parentheses are kind of implied. So, as for what the chain rule is, if I have a function, an outside function and an inside function, the derivative is of that function. You would take the derivative of the outside function with respect to the inside function, and then multiply by derivative of the inside. So you can see it. There's your outside function. Here's your inside function. We're going to take, it equals the derivative of the outside, we say, with respect to the inside, times the derivative of the inside. And what this means is, I'll take the derivative of the outside function, but I got to keep the inside just as it was, and then multiply by whatever the inside's derivative is. So it's like building a big chain link, and sometimes you have to do it multiple times. Let's look at some examples, because that's the best way to go about these. Sometimes the best thing to do first is to try to figure out what the outside and inside functions are. In this case, I have this polynomial on the inside, so I'm just going to rewrite it just so I can see it. And then the outside function would be, well, I'm taking that whole thing and cubing it. So my outside function is really like x cubed. So what I should be looking at here, we should be looking at what we can figure out, what I mean by that is with our derivative. So f prime of x is going to equal the derivative of the outside. Well, the outside function, x cubed. The way I find the derivative of that would be to bring the power out in front and lower the exponent by 1 to make it x cubed, or x squared, I mean. So what we have to do, we're bringing the 3 in front. That's derivative of the outside, but it's with respect to the inside. That means I keep the inside the exact same. So I brought my 3 down in front, and now my exponent is squared. That's the first part, derivative of the outside with respect to the inside. The last step, though, is I need to multiply by the derivative of the inside. The derivative of this inside would be 3 minus 4x. And that is a perfectly good answer. What I might recommend, if you have a linear factor out here and a number out in front, I might try to just put those together. So I would distribute that 3 into it. So this would just be 3x minus 2x squared, the whole thing squared, and then this would be 9 minus 12x. That would be your final answer. So, derivative of the outside with respect to the inside times the derivative of the inside. Here's an example. See if you can figure it out on your own. See if you can make it happen. Alright, so the outside function, in this case, is something to the 5th power. The inside function, x cubed minus 5x squared plus 1. Eventually, you should be able to get through these without having to write what the outside and inside function is, but that's a good way to get yourself started on all these. So, when I do my derivative, it's the derivative of the outside, so it's a polynomial, so 5 with respect to the inside. So keep the inside the same. I lowered my exponent by 1. That's how I took that derivative. And then times the derivative of the inside, which would be 3x squared minus 10x. And again, I could simplify that by distributing the 5 through the linear factor. I can't distribute into this part because it's raised to a power. So that would just leave me with this. 3x cubed minus 5x squared plus 1 times, this would become 15x squared minus 50x. Alright, so there's how you do chain rules with polynomials. See some other kind. This one has a square root going on here, or a cubed root, I should say. First step, if you can rewrite it, I would definitely do so. So this would be x squared minus 1, and this would be the power over root, the 2/3 power. So these should be very similar to the last ones we just did. The outside function is something to the 2/3 power. The inside function is x squared minus 1. So when I do this derivative, same idea. The derivative of the outside means I would bring the 2/3 out in front. With respect to the inside, leave the inside the same. And then to get the exponent, I lower that by 1. So 2/3 minus 1, or minus 3/3, gives you that negative 1/3. But then it's times the derivative of the inside. So there's your chain rule. Derivative of the outside with respect to the inside times derivative of the inside. And just to simplify that, when I put that through, that'll become, it should be 4/3 x for that part. And then the part with the negative 1/3 would stay the same. Negative 1/3, if you prefer, or if you're trying to match on a multiple choice answer, it would probably look something like this. A 4 and an x would be up top. You'd have a 3 and a cubed root of x squared minus 1 on the bottom. I'm perfectly fine with this answer. Just make sure you can get it to that if you need to match an answer. Your turn. Try one that's very similar. See if you can make it happen. All right, in here, I should be rewriting this. Again, power over root, so 2x minus 7. The power is 5. The root is 2. So that means that my outside function here is same thing, something to the 5/2 power. The inside is whatever was the inside, 2x minus 7. So when I do my chain rule, yet again, f prime of x is the derivative of the outside with respect to the inside. So bring my power in front, keep the inside, lower my exponent by 1, which means by 2 over 2, so this is now 3/2, then times derivative of the inside, which is just 2. To simplify that, well, the 2's should just cancel out. One's up top, one's on bottom. So 5 times 2x minus 7 to the 3/2 power. I would keep it just like that. All right, another kind. This one here is another one where you should just try to rewrite it. You have quotients going on here. Let's see if I can rewrite it. My 2 on the bottom, I can rewrite it with that being up top if it's written like this. 2t minus 3. It was positive 2 on the bottom. That makes it a negative 2 when it's up top. Now, this 7 out in front, I'm just going to kind of ignore that. That's like a coefficient I would leave out in front of everything else. Okay, so what I'm really looking at is this part right here for my function. My outside function would be, well, it's t's or x's, whatever, t to the negative 2nd power. The inside is, well, whatever that inside is, 2t minus 3. So when I do this chain rule, f prime of x will equal, remember, my coefficient out in front, I'm just going to keep it out in front. That has nothing to do with doing the chain rule. Any coefficient in front can just stay that way. Okay, derivative of the outside, meaning bring my negative 2 in front. So negative 2, excuse me, with respect to the inside, 2t minus 3, my exponent is lowered by 1, times the derivative of the inside, which is 2. As I simplify that, I got negative 7 times negative 2 is positive 14, times 2 again is positive 28. 28 times this 2t minus 3 to the negative 3rd, which can simplify more. 28 over, I can bring this down to the bottom now. 2t minus 3, positive 3 is what it would be on the bottom. So if you have a coefficient in front, you can just leave it in front, or like we've done before, you could have just, when you brought this down, said what is 7 times 2. That's how you could have gotten 14 that way as well. Here's one for you to try. See if you can get it done. I would have rewritten this as 14 times 41. It's again t squared minus 1 to the negative 3rd power is how I bring that up to the top. Okay? The outside function again, and again, if you can do these without having to write this down every time, kudos to you. T to the negative 3rd power, the inside should be 41 t squared minus 1. So, to do this derivative, let's do it like we did up top. F prime of x, or really it should be t, whatever, is equal to derivative of the outside. So when I bring that negative 3 out in front, 3 times 14, excuse me, should give you a 42. So negative 42. I keep the inside the same, because it's with respect to the inside, and I lower my exponent by 1, times derivative of the inside, which would be 82t. I would then simplify that by doing whatever 42 times 82 is. So this should become 3444, and then this can go on the bottom, which would be as 41t squared minus 1 to the positive 4th power once it's on the bottom. All right, one last kind to try, a trig function, and really it's no different than the ones we've done before. The outside function is going to be your trig function. So the outside is sine of x, the inside is 3x squared minus 4x. So when I do this derivative, f prime of x, derivative of the outside, derivative of sine is cosine. With respect to the inside, that means I keep the inside the exact same, and then it's times the derivative of the inside, which is 6x minus 4. Now, the only thing I would probably do here is the more standard form to have the polynomial part go in front of the trig function. There's no right or wrong way there. That's just the more formal way to say it. So now you've got one to try. See if you can do it. The outside function should be your trig function. Your inside function is whatever is inside those parentheses. F prime of x will equal the derivative of the outside. Derivative of tangent is secant squared. With respect to the inside, means you keep the inside the exact same, times the derivative of the inside. Derivative of that inside is 2x plus 6. And again, I can rewrite it like I did up top, putting the polynomial in front, just like so. And that's all you need to do. Now, one thing to make sure of, make sure you don't try to distribute inside a trig function. These trig functions are locked in just as they are. You cannot distribute or anything into them. All right, well, there's your crash course on the chain rule. What we'll learn in the next lesson is how to do problems where you have chain rule, quotient rule, product rule, all the above, working within each other. Have a good day.